Today's lesson is on infinite series. Just as a reminder, your test over Unit 6 will be next week on Wednesday. So the test is next week on Wednesday. So for today, for your infinite series, we're going to talk about when sequences or series converge or diverge. So the convergence of a sequence, A sub n, remember a sequence is a list of numbers, converges if the terms approach a limit as n goes to infinity. They have to approach a specific number as n goes to infinity. So that would be like approaches a horizontal line if you're looking at a graph. If not, then we say that the sequence diverges. So it converges if it approaches a limit. If it doesn't approach a limit, then it diverges. A series, remember this is what a series looks like, converges if the sums approach a limit as x approaches infinity. When a series converges, it is often written as the summation of a sub n when n equals 1 to infinity. So there's an infinity symbol on the upper bound. On the first table, it says use the given formulas to generate the first three terms of each sequence. Then tell whether each sequence would converge. If the sequence does converge, tell the limit of the terms as n approaches infinity. So number one, I have a sub n equals 4 minus 1/2 n. So for my sequence, let's let n be equal to 1 first. So 3 minus 1/2 times 1 will be 3.5. Okay. If I let n be 2, 4 minus 1/2 times 2 will be 3. And if n is 3, to get the third term, it'd be 4 minus 1/2 times 3, I get 2.5. Now, you have to realize this keeps going. I just listed the first three terms. Okay. So I want to know, does this converge? Think about it. If it keeps going, I'm going to keep subtracting, if you look at it, 1/2 every single time. Is it going to approach a specific number? No, because it's going to keep going, and it's actually going to end up in negative numbers and keep going. So if it does not converge, you don't have to fill in the last box. On number 2, a sub n equals 16 times 1/2 raised to the n minus 1. So if we go through this, plug in 1 for my first term, 16 times 1/2 raised to the n, so the 1 minus 1, that will be 16. Then if I let n be 2, it'll be 16 times 1/2 raised to the 2 minus 1, and I get 8. If n is 3, I get 16 times 1/2 raised to the 3 minus 1, and I get 4. It's going to keep going, but think about it, what it keeps going to. If you look, I'm multiplying by 1/2 each time. So then after 4, I would have a 2, and then a 1/2, and then a 1/4, and then a 1/8. It's never going to become 0. It's just going to keep getting closer and closer to 0. So does it converge? Yes. And when it asks to what? Well, it's going to get closer and closer to 0. On the next section, it says below, find the indicated terms and evaluate the given series to decide whether it converges. So on number 3, I'm given a sub n equals 27 times 1/3 raised to the n. So I want to find the 20th term. So I'm going to raise that to the 20th power. If you do that in your calculator, it's probably going to give you 7.7 and then a bunch of numbers, e negative 9. That means that decimal should be moved to the left 9 times. So this is really going to be 0.1234567. Okay, so 6 zeros and a 7. Now, if I let n be 30, now I get 1.311 and then e to the negative 13. So when I write this number, it's going to have 12 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then a 1, 3. Okay. So do these terms converge? Are they getting closer and closer to a specific number or a specific value? Yes, they're getting closer and closer to 0. Now it wants me to find the series. I would use the summation key on your calculator, if you have a calculator that does the summation, and type in this summation. But in your a sub n, you've got to put the 27 times your 1/3 raised to the x. Okay. So what it's doing, it's going to add up all of the terms, the first 20 terms. And when I do this, I get 13.5. Okay. And then if I find the summation of the first 30 terms, I change that 20 to a 30, I get 13.5. So it's getting it's getting closer and closer to this number. I could do this again, and let's change maybe that 30 to a 100 and say for the first 100 terms. And my calculator is thinking. Again, it gives me 13.5. So it's approaching the same number. So yes, the series converge. Okay. Number 4 is b sub n equals 5 plus 2n. So if b is 20, I'm going to have 5 plus 2 times 20, which is 45. If I let b be 100, I'm going to have 5 plus 2 times 100, and I get 205. These numbers are nowhere close to each other, so they're not getting closer and closer to the same number. So do the terms converge? That would be a no. And now for my summation, I'm going from x equaling 1 to 20 of this function 5 plus 2x. If I type that in, the series of this, if I add all those together, I get 500. Then if I change that 20 to a 100, because I want the sum of the first 100 terms. Oh, and this 500 is wrong. Hold on, I typed a number in wrong. I'll go back to it in a second. This is 10,000 of the first 100 terms is 10,600. Now let me go back and refigure the other one. I typed in a 4 instead of a 5. It's actually 520. But again, they're not getting closer and closer to the same number. So this is no, the series do not converge. Now, we were talking about what we call finite series because I'm looking at the first 20 terms or the first 100 terms. We also have something called an infinite geometric series. An infinite geometric series of the form, the summation of my explicit formula, a sub 1 of r raised to the n minus 1, from n equaling 1 to infinity, converges when the absolute value of r is less than 1. And then the sum of the infinite series can be found using this formula. Okay? So one thing you have to realize, if it's an arithmetic series, it will always diverge or be divergent. Geometric series, if r is greater than 1, it diverges. But if the absolute value of r is less than 1, it converges. And here is this formula for finding the sum of the series, the infinite series. So this is, you only use this formula when there's an infinity symbol as your upper bound. So for the formula, I need to know what a sub 1 is and r. So for this formula, a sub 1 is 2, because this is the explicit formula, and r is 1/4. So my sum is going to equal this fraction, a sub 1, which is 2, over 1 minus r, so minus 1/4. So type that in as a fraction into your calculator, 2 over 1 minus 1/4. And this is going to be approximately, I'm going to round to 2 decimal places, 2.67. Remember, if you have any questions, I will be on Zoom during Zoom tutorials. I will also be posting answer keys to this week's assignments at the beginning of next week. So you can check your answers, and if you have questions, you can come on before the test, either Monday or Tuesday, and get those